Hello friends, now we will discuss about the graph of modulus function and greatest integer function. So first we take the modulus function, and we know the modulus means absolute value. So absolute value cannot be negative. So mod of for when x is positive or negative. In both the case, we will get the value of fx or y as positive. So by definition, fx equals to x when x is greater than equals to 0. So when x is greater than equals to 0, we are making the graph as y equals to x, and it is behave like an identity function y is equal to x. So for all values of x, if you take 0, y is equal to 0. If you take 1, y is equal to 1. If you take 2, y is 2. If you take 3, y is 3. So the points are 0, 0, 1, 1, 2, 2, 3, 3. So when you plot the points and add up, we'll get a line starting from origin and extend towards positive infinity. So in this case, for all real numbers or values of x, we are getting y also odd real number. And if you do the parallel line test, so for every x, for each x, we are getting a single value of y. So this is a function. And now if we take the negative values, so when it is minus 3, so here y is equals to minus x. So when you put x equal to minus 3, it minus or minus, it becomes 3. When you put minus 2, x equal to minus 2, so minus or minus 2, it becomes plus 2. When if you put minus 1, it is minus or minus 1 plus 1. So here the values are coming. When x is minus 1, y is 1. X is minus 2, y is 2. X is minus 3, y is 3. So no part of the function coming in the negative side. So here the domain, all near numbers from 0 to infinity and from 0 to minus infinity. So this is R. But the range of it from 0 to infinity, because no part of the function below the x-axis. So it is 0 to infinity. So this is the modular function, and the domain is R or real numbers, or you can say minus infinity to plus infinity, and the range of R, all positive values from 0 to infinity, including 0. Now, another function, it is greatest integer function. So, before we start the graph of this one, we first want to say what is greatest integer function. So, here, the greatest integer function is defined as box x. It is called box, and the box x is equals to an integer. N is an integer here, less than equals to x. So suppose it is 1.1. So when x is 1.1, so 1.1, what are the integers lesser than 1.1? 1, 0, minus 1, etc. So among these, 1 is the greatest. So that's why we are taking the greatest value as 1. For 1.2, it is again 1. 1.99, it is 1. If it is 2.5, so the value will be 2. So here some facts about the greatest integer function. Greatest integer function x, when taking the value real number x, the value is x when x is an integer. That is, box of 1 is 1, box of 2 is equals to 2. So when it is in x is an integer, we are getting the same value x, but box is equal to integer if it is less than x. If x is not an integer, in this case 1.1 or 1.2, 1.99 will take 1. So here it is clearly written, if box is equals to, we take k, where k is an integer. If and only if x lies between k and k plus 1. So by this definition, if we take x between -2 less than equals to x and less than 1, in this interval the value will be -2 as it is k. Similarly, from -1 to 0, x greater than equals to -1 and less than 0, the value will be -1. Between 0 and 1, the value will be 0. Between 1 and 2, the value will be 1. So here we are plotting first -2 to -1, or another one is -3 to -2. This value -3 and the value of -2 here follow circle because not x is not included in -2. Similarly, when x is equals to from -2 to 0, -2 to -1, the value, all values are -2. So from 0 to 1, all values are 0. From 1 to 2, all values are 1. And then if we take 2 to 3, the value will be 2. This is also a step function, because if you just put the dotted, it looks like a step. This, then this, then this. So this is like a step function. And what is the domain? Domain is all real numbers and range is an integer. Here it is 1, here it is 2, here it is -1, it is -2. So domain is equal to R and range is equal to set of integers. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.